Hey, what's up guys? It's Mr. Ipock with a follow-up video from today's lesson, lesson 2.1, dealing with multiplication and exponents. Okay, this is just a follow-up video, just to kind of, if you get home, you get stuck, you're not sure exactly what you're doing, maybe this video can kind of help you out, get you going with your homework. I'm just going to work through a few problems and then also pick out some problems from tonight's homework assignment. So, starting with multiplying powers with the same base. Anytime you're multiplying numbers with exponents and they have the same base, you're just going to simply add the exponents. This makes sense because this is in exponential form. If I take it to expanded form, it looks like this: 6 times 6, which is here, and then 6 times 6 times 6 times 6. 1, 2, 3, 4, 5, 6. 6 factors of 6 makes that 6 to the 6th power. Or simply just say 6, 2 plus 4, which is equal to 6 to the 6th power. So anytime you're adding numbers with exponents and they have the same base, you can just simply add the exponents. Okay? Going to a power of a power. This is where we have a power, which is 4 squared, to another power, which is 3. When I write this out in expanded form, it looks like this: 4 squared times 4 squared times 4 squared. So that means that all these bases here are the same. So I can apply this rule of multiplying powers with the same base. They all have the same base. So now I can just simply add the exponents. 4, 2 plus 2 plus 2, which equals 4 to the 6th power. The shortcut method of not extending out to expanding it out would just be to multiply. I've taught this in class. You guys just go ahead and multiply that. 2 times 3, so 4. 2 times 3 is going to be equal to 4 to the 6th power. Same method here. Last is the power of a product. This is the last thing we discussed today. And this is dealing with a power of a product. Since this is being multiplied, the result is a product. Okay? This in expanded form looks like this: 2m squared times 2m squared times 2m squared. Notice, I have 1, 2, 3 2's, 1, 2, 3 m's, or 3 m squareds. So what I need to do, the shortcut, is just to distribute this 3 into every factor in the parentheses. So I put the cube on the 2, I put the cube on the m squared. So therefore I can write this as this: 2 cubed times the quantity of m squared cubed. I attach the cube to the 2 and I attach the cube to the m squared. 2 cubed is 2 times 2 times 2, which is 8. And m squared to the third is a power of a power. So I can just multiply those and I get m to the 6th power. This is my final answer. Okay? That's just kind of a recap of what we talked about today. Again, you can kind of slow it down, the video down, and kind of go from there. Now I'm going to just take some time and just work some simple problems from the homework tonight. Okay? Just to kind of give you a head start, just in case you didn't get a good understanding in class today. Okay, I'm going to start with number 7 from tonight's homework. Now, to my advanced students, your homework's a little bit different than this, so it's different problems, but you guys should get the idea of this from this, okay? You should get the concept. So 7 is the quantity of 5a cubed times a. So you ask yourself, is this multiplying exponents with the same base, multiplying a power of power? What is this? This is multiplying a power of a product. They're being multiplied, which is the result is a product. So I need to distribute the 3 onto the 5 and the 3 onto the a cubed. This gives me 5 cubed times the quantity of a cubed times a. From here I solve. 5 cubed is 125 times, this is a power of a power, so I multiply a to the 9th times a. From here I have, I'm multiplying two variables that have the same base, a and a. Now there's not a variable here, but we know that the variable would be 1. So when I'm multiplying numbers or variables with the same base, then I add the exponents. So this would be 125a, 9 plus 1 is 10 to the 10th power. 125a to the 10th power. Look at number 8 from tonight's homework. Number 8 is the quantity of a squared times 2a squared. Okay? So what I need to do is this is a power of a product. I need to distribute the 2 onto the a squared, the 2 onto the 2, and then the 2 also on the a. So now this becomes this. The quantity of a squared times 2 squared times a squared. So this is a power of a power. When I have this, I multiply. So I have a to the 4th times 2 squared is 4 times a squared. Now as you see this, multiplication, due to the community property, you can move these however you want. So I'm going to move this around, and I'm going to actually rewrite it as 4 times a to the 4th times a to the 2nd. Now I see that I'm multiplying with two numbers or two variables with the same base, a to the 4th times a to the 2nd. Since this is the same base, I can add these exponents. So I have 4 times a. Once you add these exponents, 4 plus 2 is 6. So 4a to the 6th, my finished product is 4a to the 6th power. And that's my final answer there. Last one I'm going to work is number 10. Number 10 is the quantity of 3r squared cubed times 4r. Now I have a power of a product here because there's multiplying. So I'm going to attach the 3 to the 3 here and the 3 to the r squared. So therefore giving me this. 3 cubed times the quantity of r squared cubed times 4r. From here I simplify. 3 cubed is 27. 3 times 3 times 3 times, this is a power of a power, so I'll multiply. R to the 6 times 4r. Now I'm going to write this just a little bit differently, and I'm going to say 27 r to the 6 times 4r. Okay? So from here, I now have two coefficients, so I need to multiply these coefficients. 27 times 4. Now you can break it apart and say 20 times 4 is 80, and 7 times 4 is 28, so the answer is 108, or excuse me, 108. Or you can come to the side, right? 27 times 4, 7 times 4 is 28. 4 times 2 is 8, plus 2 is 100. As I said, 108, so I have 108. That takes care of the coefficients. Now I have r to the 6 times r to the 1st. When I'm multiplying numbers or variables with like bases, I just add, so I have r to the 7th. And that completes this recap of lesson 2.1 integer exponents. Thanks, I hope it helps.